In our what to do notes, we start with the ski lift problem. Notice off on the right, we have a diagram where the x-axis has the horizontal position and the y-axis has the vertical position. In other words, this ski lift is moving up the mountain, and as it travels a certain distance horizontally, we're looking at how much it travels vertically. So in part 1, we're asked what's the vertical change between different pairs of points. So from A to B, we don't move up very much. Notice we move from 40 to 50. Since 50 minus 40 is 10, the change in y between those 2 points is just a positive 10. So the ski lift is 10 feet higher at point B than it is at point A. From B to C, we can see that we're going from 50 up to 90. So 90 minus 50 is 40. So the change in y on that interval is 40. From C to D, we just go from 90 up to 100, and when we do that subtraction, we get 10. So the change in y is 10. Next, in part 2, we're asked about horizontal change. The horizontal change from point A to B, so that's taking us from 20 to 50. 50 minus 20 is 30, so that's the change in x. From B to C, we're going from 50 to 80. 80 minus 50 is also 30, so we have the same change in x. And lastly, from C to D, we're going from 80 to 110. 110 minus 80 is 30, so again we have the same change in x. Now we're asked to look at each of these ratios. The ratio from A to B, a vertical change to horizontal change. So from AB, we had a vertical change of 10 to a horizontal change of 30, looking at the work that we did in parts 1 and 2 above. Anytime we write a fraction, we should reduce if we can. We see that those are both divisible by 10, so the ratio of vertical change to horizontal change is 1 to 3. In B to C, pulling our numbers from above, we see we have 40 over 30, which is 4/3. Now notice 4/3 is a bigger number than 1/3. And if we look at the lines, this section is steeper than that section. From C to D, looking at our rate of change, C to D had 10 for vertical change and 30 for horizontal change, which reduces to 1/3. Now this is interesting. If you look at the section from AB and then compare it to the section on CD, notice how they're kind of at the same angle. And we can see that that's also true with their ratio of vertical change to horizontal change. It's 1/3 both times. So the steepness is the same. In part 4, we're asked which section is the steepest. And we can tell just by looking at the graph that the section from B to C is the steepest. So when we see a rate of change of 4/3 and it's bigger than 1/3, that tells us B to C is the steepest. And basically what that ratio means is that for every 4 feet of vertical change, there are 3 feet of horizontal change. So the ski lift is moving up a little bit faster than it's moving to the side. In number 5, we're looking at a new scenario. This says fee for miles driven. We see that our input, our x values, are miles, and our output, our y, is the fee, so the dollars, how much something costs. In number 5, we're asked to find the rate of change for each pair of consecutive mileage counts. So a pair of consecutive mileage counts would be from 100 to 150. We see it goes from $30 to $12. So that's a $12 increase for a 50-mile increase. So that change in y over change in x is $12 for 50 miles. That reduces to 6 over 25. Now, if we look at the next mileage count, from 150 to 200, that's 50. And from 42 to 54 is 12. Notice that's the same rate of change. And then the next pair, we have 200 to 250, that's a change of 50. And 54 to 66 is a change of 12. So this is $6 per 25 miles throughout the entire table. We're asked what this rate of change represents. Well, if we try to put this into words, we would say for each set of 25 miles driven, the cost increases by $6. Five's not very clear. Let's make that a little more clear. All right, next, in number 7, it says below is a graph of the distance traveled by a motorcycle from its starting point. So this is how far the motorcycle is from where it started at each moment. And we're asked what is the rate of change, and then to explain what this rate of change means. So we just need to pick a couple spots where it's pretty clear what the value is. Now, following along this line, this value seems pretty clear, 20, 400. It can be a little hard to tell what some of the other ones are, but 0, 0 is also pretty clear. So if we look at that interval, we can see that our change in x is 20 from 0 to 20, while our change in y is 400 from 0 to 400. So the rate of change would be the change in y over the change in x, or 400 divided by 20. Well, quickly, we see that they're both divisible by 10. And then we can see that 40 divided by 2 is 20. And we have to think about, what does that 20 actually mean? Well, remember the change in y. We've got listed m here. I'm guessing that's probably meters. So that means 20 meters for, now there's no denominator here. We remember that when we have a whole number, the denominator is really 1, and sometimes that 1 is really helpful for our understanding. Notice our unit for x is seconds. So this is 20 meters for every 1 second. Putting the units into the problem from the table, from the graph, is really going to help us to put this into words. This means that the motorcycle's speed is 20 meters per second. That's how fast the motorcycle is driving. That's what the rate of change actually tells us in this particular problem. Finally, next in number 8, what is the rate of change and what does it mean in this situation? So let's look at this graph. Again, it really helps if we identify a couple of clear points. See these points in the middle, it's sort of hard to tell what their exact coordinates might be. But this one, 160, and this last one, 120, are pretty clear. If we look at the change in x from 1 to 5, so 5 minus 1 is 4, and the change in y, we're going from 60 to 120, so 120 minus 60 is 60. When we go to make our rate of change, we can say that the change in y over change in x is 60 over 4, and we know that that divides to be an even 15. But as we saw in the previous problem, a couple things help. First of all, having the slope as a fraction instead of a whole number is actually a little bit easier. And then to go back to the problem and pull the units is also very helpful. This 15 is in dollars, and this 1 is in days. So we can see that the rate of change means the cost increases by $15 each day. That's the meaning of the rate of change. So the rate of change is 15, and this is the meaning of that in this problem. Number 9, what is the slope of each of the lines below? This is less about meaning and more about calculating. So remember there was a slope formula. The slope, which is our constant rate of change, can be calculated with y2 minus y1 over x2 minus x1. So if this is my y2 and this is my y1, I'm going to say 4 minus 1 divided by, that makes this my x2 and this my x1. So 3 minus negative 2. Well, 4 minus 1 is 3. 3 minus negative 2 is really plus. So my slope is 3/5 for this first line. Looking at my second line, I have that the slope is the same idea, y2 minus y1. So if this is my y2, that's negative 1 minus, here's my y1. That would make this my x2 minus, this is my x1. Negative 1 minus 2 is negative 3. 3 minus a negative 3 is 6. And if I reduce my fraction, I get negative 1/2 for the slope of this second line. Number 10. Find the slope of the line passing through these 2 points. This is again simply asking us to use the formula. Now, just to show you, we've typically taken this point and subtracted off the values of that one. But it actually doesn't matter which order we go in as long as we're consistent in the problem. So this time I'm going to do it the other way. The slope is the change in y divided by the change in x. If I start here, I'll say 5 minus 7 for my numerator, which means I have to start here again, 2 minus 4 for my denominator. Well, 5 minus 7 is negative 2. 2 minus 4 is also negative 2, so this slope is 1. If I'd done the problem in reverse, and I chose to start here, I could say that my slope is 7 minus 5 divided by 4 minus 2. Notice that gives me a positive 2 divided by a positive 2, which still simplifies to be 1 in the end. So it doesn't matter which order we choose to tackle this slope formula. Now don't get scared by number 11. Just because there's fractions doesn't mean it's a problem. We do the work the very same way. So I'm going to choose to start here. I'm going to say that my change in y over my change in x has 1/3 minus 3/4. There's my y values. And then going in the same order, 3/5 minus 1/2. Now we can see we basically have 2 subtraction problems to do, so I'm going to do the fractions out off on the side. If I have 1/3 minus 3/4, remember I need a common denominator. And since 3 and 4 have the least common multiple of 12, that will be my common denominator. For the top fraction, I would have to multiply the 3 by 4 to get 12. So I also have to multiply 1 by 4. So I'm going to have 4/12. For this bottom fraction, 4 times 3 would give me 12. So 3 times 3 gives me 9. This is a subtraction problem. So 4 minus 9 is negative 5. So I'm going to have negative 5/12 for my numerator. Now I've got another little subtraction problem to do. 3/5 minus 1/2. This time my common denominator will be 10. 5 times 2 would be 10, so 3 times 2 is 6. 2 times 5 would be 10, so 1 times 5 is 5. This time when I subtract, I get 1/10. Now I have to remember my basic fraction skills. When I'm dividing 2 fractions, I take the reciprocal of the second fraction and multiply. So this is the same as negative 5/12 divided by 1/10. So that means this is the fraction that has to flip. Negative 5/12 times 10 over 1. And we want to do multiplication the high school way. We want to reduce before we multiply. 10 and 12 are both divisible by 2, so I'm going to reduce my fraction. So this gives me negative 25 over 6. So that's my rate of change for this particular problem.